Hello, everyone. My name is Michael Brennis. I'm with SSDI, the State Smart Transportation Initiative. I'd like to welcome you to the next in our series of Measuring Accessibility webinars. This one's subtitled Expanding the Practice. We're going to introduce an interactive element here in a second, a poll to show you while folks are filtering in. If you would like to just let us know what brought you here today, we'll share the results of that and maybe get a better idea of who's in our audience and how we might customize these webinars going forward. While we're looking at that, just a couple of housekeeping items. The webinar today is being recorded, so the recording will be available on our website, ssdi.us, shortly after the conclusion of the session. We also encourage questions. If you would use the question and answer feature at the bottom of your screen, type your questions in there rather than the chat. We'll get to as many of those as we have time for at the end of our session. SSDI is a joint project of UW-Madison and the Smart Growth America. And we focus on promoting sustainable, equitable transportation practices and assisting agencies in advancing such programs. The three pillars of our approach include a community of practice, where state DOT leaders can share challenges and best practices with leaders from other states. We offer knowledge sharing, along the lines of what we're doing today with this webinar. We also publish a blog and newsletter examining applications of current research, trends in travel behavior, and other transportation and land use issues that our audience may find interesting. And thirdly, we conduct research and offer technical assistance to agencies interested in what we can provide. I encourage you, if you're interested, to sign up for our newsletter at ssdi.us. And if you wouldn't mind taking the survey, that will be distributed after the webinar. I think everyone can see the results of the poll. Looks like a pretty even distribution across the 6 areas of interest there. We'll assume that most folks today have some familiarity with accessibility analysis, which is a quick overview. It's sometimes referred to as access to destinations or access to opportunities. It allows us to better characterize the extent to which people can use our transportation systems to participate in our society. We've seen exponential growth in the number of papers on the subject published in the academic press as accessibility tools have become more widely available and users broaden their understanding of how accessibility analysis can be applied. We here at SSDI are keenly interested in understanding the degree to which accessibility is being adopted into the practices of transportation agencies and in assimilating the advances and innovations coming from the academic realm. For those wishing to explore available tools and techniques, the SSDI Measuring Accessibility Guidebook, that's available on our website, may be a good launching point. Today, we're going to hear from 2 academics whose ongoing research is central to our understanding of accessibility and the degree to which it can become an essential tool for transportation and land use planning and operations at all levels. Our speakers today, Louis Merlin is an associate professor in the Department of Urban and Regional Planning at Florida Atlantic University and the program coordinator for the Master of Urban and Regional Planning program. Dr. Merlin draws upon a strong background in mathematics and operations research and experience as a professional urban planner. He's particularly interested in developing mathematical models that shed insight into pressing urban policy questions. Dana Rowangould is an assistant professor in the Department of Civil and Environmental Engineering at the University of Vermont. Drawing from the fields of engineering, economics, and the social sciences, Dr. Rowangould's research includes rural transportation behavior, transportation equity and justice, transportation and land use planning, energy use and air quality, and multimodal transportation. Her work is motivated by a desire to improve transportation systems so that they better serve people, particularly those whose ability to travel is constrained by their individual needs and transportation options. Coaches tossed the coin prior to today's webinar to determine the speaker order, and we will begin with Professor Merlin.
Well, let me see if I can get my slides going here. Can you all see my slides? Okay, I'll take that as, yeah, okay, thank you. So today what I want to talk about is pedestrian accessibility measurement, the current state of pedestrian accessibility measurement. I recently worked on a paper along with my co-author Ulrike Jelle on a literature review on pedestrian accessibility, and that's been published in Transport Reviews. And this is basically a summary of that paper with more of a focus on a practice audience. Planning practice, transportation planning practice audience. Okay. So there's a lot of ways of thinking about walkability. There's a lot of different kinds of measurement systems. I was reading about a measurement system earlier today that's very popular called PEDS. What I'm going to do at the beginning of this is make an argument for why we want to think about walking specifically in terms of accessibility. And in a nutshell, it's because accessibility has a very rich theoretical framework on which to draw. It helps to focus our understanding of walkability and to measure it effectively. So what are we trying to improve when we're trying to improve walkability? Well, I would argue that what we're trying to improve is people's ability to reach destinations. So what we see in this picture here is we see, of course, an origin, a destination, a route, and a person. That's also very important. We're talking about a person. So can this person get from their origin to their destination on foot, right? And that question is an accessibility question. There are all kinds of other walkability measures out there, but if we want to answer that question, we want to use the framework of accessibility. Also, a really strong point that accessibility has going for it is this framework that was laid out 2 decades ago by Gers and Van Wee with the 4 dimensions of accessibility. And this will come up again and again throughout my discussion. The transportation infrastructure, which of course we all think about, the land use pattern, which I think more and more of us are thinking about, but also the characteristics of the individual and the time of day. Those also tend to be very important when it comes to walking, as we'll see as I go through this paper. The other reason we want to think about walking in terms of accessibility is because accessibility gives us means to both quantify and map, illustrate the current state and the value of improvements. Generally, we don't have many pedestrian trip counters, and the levels of pedestrian trips are generally much smaller than the level of vehicle trips. So that means it's very difficult to measure the improvements that we make to the pedestrian environment through increases in trips, increases in observed trips. There's very few counters except for in the most highly traveled segments. I also would argue that pedestrian trips are highly suppressed. And by that I mean origins and destinations can be close by, but if they are not safe and comfortable, the pedestrian trips may be very few. And the value of accessibility is it enables us to quantify and visualize the current pedestrian environment and improvements to the environment. So here on the right, just for an example, we have a table of the number of people in a certain neighborhood who can reach schools, banks, pharmacies, dentists with a 15-minute walk. So this is, there's of course many different kinds of accessibility measures. Maybe my co-presenter will talk about some of those different measures, but this is just one example of the kinds of ways we can quantify accessibility in the pedestrian area. And likewise, we can map accessibility, right? So these are heat maps with green representing the most accessible areas and red representing the least accessible areas. I think this map is accessibility to parks. And what you see here is if we do some scenario analysis, if we introduce some new parks, you can see the area that's highly accessible can vastly increase, and the area that's inaccessible can decrease. So accessibility gives us a very useful framework for measuring the current state, for comparing different places, and for comparing scenarios. So I think that's why we want to use accessibility analysis for understanding pedestrians. So now I'm going to launch into the actual literature review, what we did and what we found, concluding with some recommendations. So this is a bit of a reiteration of my main point, which is my previous point, which is that there are many different measures of walkability. Walkability, also there's multiple competing definitions of walkability. I think by focusing on walk accessibility or walking accessibility, we get a much more narrowly conceptualized topic, and we can conduct a more effective literature review on that topic. So it's interesting because when we worked on this paper, there were some previous literature reviews, but none of them really had focused on the topic of walk accessibility adequately. So we had two key criteria for what we consider to be a walking accessibility paper. One is there had to be walking to destinations. Some kind of destination had to be considered. So, for example, walking for health or for recreation would be excluded from this definition. Second is there has to be some measure of distance or cost or impedance. So there's various ways to measure impedance. Distance is the most common way. But if you're not measuring some kind of measure of cost, then you're not really taking into account accessibility. So this is just a brief summary of what we actually did. We looked at 3 different databases, Web of Science, Google Scholar, and the Transportation Research Database, and looked for 2 sets of terms, one set of terms related to pedestrians and another set of terms related to accessibility. And our initial search, we found 181 papers. And then we filtered those papers mainly through the criteria that I already discussed with you, which is that there has to be some kind of walking to destinations, there has to be a measure of cost or impedance, and the primary mode of travel has to be walking. And once we did this, we whittled down to 85 papers that were actually analyzed. A couple of key points before I get into a summary of the results. One is how global the interest in walking accessibility is. You can see from this map that the largest number of papers were in Europe, followed by North America, but we also saw South America, Africa, Asia, Australia. Of course, I think this is because walking is universally required. Walking occurs across the globe and in all cities and across all populations. It's relevant really no matter where you go. Also interesting is the time trend with regard to these papers. The earliest paper we found was from 1997, which is kind of when GIS is taking off. And then once we get to the 2020s, we are starting to see about 10 papers a year on this topic. Okay, so how did we actually do this analysis? Kind of foreshadowed this earlier. Following the framework of Gers and Van Wee, we looked at the 4 dimensions: transportation, land use, individual, and temporal. And for each paper, we extracted how did they approach each of these 4 dimensions, looking for trends, unusual approaches, contrasts, anything we could to find patterns in what's been done and what are the new emerging ideas with regard to all of these dimensions. And then lastly, we also considered impedance. How is impedance calculated? Because again, that's a central concept to what you can reach by foot. So I'm gonna launch straight into the main findings, which are going to be organized by these 4 dimensions. First, the first dimension is the transportation dimension. So the main challenge here is that most places don't have the data that's needed for a fully developed pedestrian network, or even a partially developed pedestrian network. Most of the studies, overwhelmingly, that we reviewed just used the roadway network with some minor modifications. So maybe they took out some highways, maybe they added some pedestrian bridges, but mostly they just used the roadway network. In a handful of cases, we saw researchers go to substantial trouble to develop very detailed pedestrian networks, mostly through firsthand data collection. So they usually would visit the site, gather all the data on every single street segment, and put it into GIS, and then do their calculations. Also, what you consider to be a pedestrian network actually can depend upon the user type. So, for example, if you have some non-paved routes, you might not include them if you're considering wheelchair using persons. So there's some interaction here actually between the individual dimension and the transport dimension. And several papers looked at more complete or less complete networks of pedestrian networks. And as you would expect, if you have a more complete network, your accessibility is going to change. So having that accurate network does, in fact, matter. Land use enters into pedestrian accessibility in multiple ways, some ways you might expect and other ways you might not expect as much. Of course, the origins and the destinations are both land use features. Most accessibility studies start at residences. We also had some studies that looked at every single building in the study area as a potential origin, or every possible location within the street grid as a possible origin. Destinations for walking accessibility are quite varied. It's not just jobs, but also parks, health service facilities, schools, childcare facilities, shopping centers, and transit stops. So in contrast to motorized modes, which mostly focus on, typically focus on jobs, pedestrians are using a variety of destinations, and a variety of destinations can be valued or important. The other way that land use is influential is that the land use around a segment can actually influence the experienced impedance. So just to give two brief examples of this, when people walk along active commercial streets, they actually experience that as less distance because of the activity, because of the distraction. It's actually experienced as a shorter distance when they're along an active commercial street. Also, some research says when people are walking along parks or green areas, that they experience the distance as a reduced distance. The individual factor. So unlike, if you take 2 or 3 people who drive, how much impedance they experience is pretty much going to relate to the time, maybe the delay in the time. But for walking, it's quite individualized. Every person really has a very different experience when walking. And so the individual factor is extremely important. Some of the factors that have been considered include age, gender, income, health, mobility constraints, vision constraints, and vehicle ownership. And the most common populations that have been studied have been older adults and wheelchair users. So we saw several studies that focused on these two populations. Surprisingly, we saw very few studies that focused on the individual walking needs of children, which I was surprised by. In addition, we saw what you might characterize as 2 different approaches. One is a population segment approach, where we look at groups such as older adults or wheelchair users. The other approach is what we call the fully individualized approach, where all the characteristics of a person are taken into account and a customized impedance is created for that specific person. So that's an interesting approach as well. Similarly to the individual dimension, the temporal dimension is relatively unstudied. We only saw a couple of papers that really delved into the temporal dimension. Now, how does the temporal dimension matter for pedestrian accessibility? Well, the 2 ways that seem to be the most important are weather and lighting conditions. So people's experience of impedance when the weather is pleasant is very different than when it's raining, and it's very different than when it's like it is now, extremely hot and humid. It's also different whether it's daytime or nighttime. People are not always comfortable walking on certain routes or segments in the dark. So there's at least two ways that the temporal factor can matter a great deal. And just to give two examples of that, Arith et al. Found that shaded and covered routes were preferred in hot and sunny Singapore. And that's where I live in Florida. That would probably be the case as well. So in this case, the transportation infrastructure, or you could consider it land use infrastructure, but the amount of shade provided interacts with the temporal factors of weather. And Jella has another paper where she looks at how accessibility to destinations varies by opening hours, the hours of the day. So time can be another important dimension, and that is another relatively neglected dimension of walking accessibility. So this is kind of one of the key points, which is we found that for each of the dimensions, the transport dimension, the land use dimension, the individual dimension, and the temporal dimension, each of these has multiple ways that they can impact impedance, and there are interactions between these dimensions. So just to take one example, if we look at the consideration of nighttime travel, which the impedance is different than daytime travel, having lighting infrastructure can mitigate that challenge or that problem. So this is a place where the transportation infrastructure can mitigate the temporal variation from between daytime and nighttime. So the upshot is that it's actually quite complex to take into account all of these factors. In particular, the number of transport factors for pedestrians. And I didn't go into this into a great detail, but the number of transport factors that affect pedestrians is quite numerous. So I'm going to kind of just dive right into our main recommendations. So this is from the paper, and of course there's more detail in the paper. I want to just leave you with kind of, well, not leave you because I have a little more detail to share after this, but I want to highlight the main recommendation for each of the dimensions. So first, with the transportation dimension, most current studies of accessibility use the roadway network. We really recommend that people start to develop those pedestrian networks. So those of you who are at state and local planning agencies, this is really the first most important step, perhaps, is to start developing pedestrian networks that are independent of the roadway networks, including street crossings. Street crossings can pose major barriers to pedestrian travel, depending upon the width of the street, the level of traffic on the street, the length of the traffic lights. So to develop a true pedestrian network, you have to include routes on both sides of the street, if they're available on both sides of the street, and you need to identify where crossings are possible and the actual impedance posed by those crossings. In terms of land use, it's still quite common to use administrative zones such as census tracts or block groups as origins. If your study area is small enough, we would actually recommend using individual buildings. Building to building accessibility is now a possible computationally if your study area is small enough, or if you have a slightly larger study area. We've seen some people use geometric zones such as hexagons or grid cells of relatively small size, so it's much smaller than you would find for, say, a census block group as your possible origins, and to identify various destination types. The distances people are willing to walk to different destination types are quite different. So you really have to take into account destination type when you think about pedestrian accessibility. Perhaps as important as the first point is the individual dimension. We really shouldn't be treating all people as this. There's no standard person. There's no typical or normal person when it comes to walking. We really recommend that we start thinking about distinct population segments, or what we're going to call population profiles. Thinking similarly to the level of traffic stress literature, if you want to be very inclusive, if you want to include older adults and children, you really have to think about almost a different set of needs. And then in terms of the temporal dimension, it's rarely considered. We think the most important effects to consider are the effects of weather and nighttime. Oh, and lastly, with regard to impedance, most papers use distance as their measure of impedance, which is perfectly reasonable. But there are some benefits to thinking about time, right? And we are starting to talk about time because of the 15-minute city. But some of the advantages of time are that you can account for different walking speeds, right? Well, an older person's 15-minute city might be different than a younger person's 15-minute city, or a wheelchair user's 15-minute city. The other thing that time can fold into it is you can actually assign a time to the street crossings. And therefore, by assigning a time to the street crossings, you can take those street crossings into account. Okay, so I'm going to leave with a couple of practical recommendations. I'm getting ready to wrap up here. Let me make sure I'm not over time too much. Oh, I'm getting close to overtime. I'm going to give like 30 seconds to each of these slides. This is a reiteration. Really, I think we should start to be developing pedestrian networks. So that means separate paths for each side of the street and including crossings and crossing types. Also features such as obstacles, something, there's obstacles for wheelchair users that might not be obstacles for non-wheelchair users. Slope can be very important. The surface can also be important. Using pedestrian profiles, so not treating all pedestrians as the same. These figures are not based in research. I just wanted to show how we could have different pedestrian profiles with different speeds and different factors that they would consider to be available or unavailable infrastructure, and different factors they would consider to be obstacles. So depending on who the person is, one person might find something to be an obstacle and another person might not. And I did want to make a plug. I wasn't part of developing this GOAT software, this Geo Open Accessibility Tool software. But my co-author was, Ulrike was part of this software, and they actually run and manage the software. You can see they use hexagons as their unit of analysis. I have, as a user, as an end user, I found this software to be an excellent place to start. It makes the analysis of pedestrian accessibility much easier, including the analysis of scenarios and mapping and heat maps and so forth. If you're just starting out, I would definitely give this tool a look. Okay, I want to leave enough time for the next presenter, but I'll just close with this paper is published in Transport Reviews, and this is the link if you're looking for the paper. So thank you very much for your attention.
Thank you, Dr. Merlin. Some very interesting material there. We've got some good questions coming through, including some of my own, which I look forward to asking later in the webinar. We'll pass the baton now to Professor Rowangould.
Thank you. Let me just share my presentation. And can everyone see that?
Yes.
Great. All right, so thank you for that introduction, Michael, and also Louis for that the talk on pedestrian accessibility. I think a lot of the points you touched on are things that we found in our work as well, and so we can have a little bit of dialogue about it. I'm going to talk today about some work that I did with some colleagues at UT Austin and at Kinetics, and this is work that we did trying to assess the landscape of how accessibility is used in practice, and then trying to come up with some pointers for how to advance accessibility moving forward. And I'm Dana Rowangould at University of Vermont. So we've already talked a bit about this, but I'm just going to present one more schematic of accessibility because this one corresponds, I think, most closely to the measure that we found was most commonly used in the space of accessibility measurement. So this is just a little schematic. You can imagine a person living at that center point, that kind of orangish circle, and they can travel to all these different destinations with different travel times. We can draw a line around all the places they can reach within a certain amount of time, let's say 45 minutes, and then we can count up those places. And then we have a measure of how many places of this type that they can reach within 45 minutes. So this is a very common approach to accessibility measurement. The really common example is jobs within 45 minutes. We can do this using real data and generate all sorts of maps of lots of different types of measures. This type, as well as lots of others, not just jobs, but hospitals, schools, grocery stores. And then there are other types of measures that aren't necessarily this kind of bundle of the opportunities you can reach within a certain amount of time that I'll speak about in a moment. And I also want to just mention, and this came up a lot in the work that we did for this, why accessibility is so different from other performance measures. And I think Louis got at this with his discussion as well of land use and how important that is for accessibility. So traditionally, when we think about performance measurement as we're deciding what projects to fund or how we design projects and plans, traditionally we were thinking about mobility and we were thinking a lot about congestion relief. When we think about congestion relief, we're really emphasizing movement of vehicles through space, and that has a tendency to sort of give the benefit to projects that do things like expand capacity. And that's kind of something that we've moved beyond at this point. It's not that we no longer worry about congestion, it's that we also worry about accessibility, which is how easy it is for people to reach the destinations that they want and need to go to. And that kind of opens the door to talking about other modes, walking, as Louis talked about, biking, transit, and it also opens the door to thinking about land use interventions. So that's the sort of framework that we use when we think about accessibility measurement. And when we think about the measures that we design, we're thinking a lot about their ability to capture some of those other things, depending on the context where we're going to use the measure. So I'm going to talk now about this work that I mentioned that I did with some colleagues. This was work in support of an NCHRP report, National Cooperative Highway Research Program. And ultimately, this research culminated in a guide for how to use accessibility measurement in practice. So I'm going to talk about a subset of the research we did, just looking at the landscape of how accessibility is used right now. And then I'm going to just give you a little bit of an intro to the guide itself and some of the things in the guide that I think are useful that I want to point you to. So the research behind the guide included a really extensive review of academic literature, as well as agency documents that use accessibility. And what we were looking for there was, what are the different ways that people measure accessibility? What kind of application areas are they using? How do they formulate these measures? What is the landscape that we're looking at with accessibility measurement? And it turns out it's quite broad. So, there are some measures that are commonly used, but there are lots of other measures out there. There's lots of application areas, lots of different details you can tweak to make different measures for different contexts. So building on that, our next step was to do interviews with practitioners, so planners and engineers at MPOs and DOTs and consulting companies. We also spoke with people that create software and data that are used to evaluate accessibility. And those interviews really focused on how people are using accessibility in all space and what they see as the opportunities for expanding the use of accessibility measurement in their particular area. And then we followed this with a survey of those practitioners. So with all that information, we put together a draft guidance document, and then we piloted it with 5 agencies around the US, and then we finalized the document. So it's available now. I'll provide a link at the end, and I think there might be a link at the chat at some point. But this is pretty comprehensive guidance for how to apply accessibility measurement in practice. So before I talk about the guide, I just want to give some background about what we heard from people about how they're using accessibility and the challenges they face. So one of the really common things that came up in our interviews was that people using accessibility and people who wanted to use it were emphatic that accessibility is really unique in its ability to capture that connection between land use and transportation, and to sort of open people's minds to think about land use in addition to just transportation infrastructure. And so a lot of people spoke about how it was really powerful. The concept itself and the measures were really powerful for expanding the conversation around how we plan transportation to include land use and multimodal options. We also heard from people that accessibility and the way that it's used and the way that it's interpreted varies across contexts. I think one of the most the clearest examples of this was that we heard a lot of different things about how accessibility is used in rural contexts. So some of the people that we spoke with who are planners in a rural area spoke about the importance of connections between rural communities and job centers and how accessibility was really helping them to understand those connections. Others spoke about how in their community, in their rural context, it was desirable to not have accessibility. So people had moved there in order to kind of get away from things. And so this was this kind of counterpoint. There was someone else we spoke to who I didn't include their quote here, but they mentioned that when they were thinking about rural accessibility, they were thinking about everything except jobs. So, you know, everyone in their community commutes X amount of time to get to a rural job, to a job center. But when they're thinking about accessibility, they're thinking about all the other things that people are doing. So the schools, the grocery store, the parks, and how close are those to where people live? So even if you have this kind of satellite community with commuters, do you have high levels of accessibility for everything else within your community? And then the last thing that was really common in these conversations was that when people were thinking about how to measure accessibility and what measures to use, they were really thinking a lot about how easy it would be to interpret and communicate it, both internally, so for other decision makers within their organization, but also externally to the general public. We heard a lot about this, and a lot of the kind of pros and cons that came up around different specific types of measures really centered on the ability to communicate about those measures. When we asked people how they were using accessibility, a couple of measures came up as very commonly used. So the first type of measure were proximity measures. So proximity measures are those that focus on the distance or travel time to transportation infrastructure. So this might be, for example, the distance to the nearest transit stop or the percent of the population that lives within a quarter of a mile of transit. And then the other one that was very common were access to opportunities measures. And so that example that I highlighted initially, which was jobs within 45 minutes, is an access to opportunities measure. And those can be formulated lots of different ways, but that was the most commonly used measure. There were several other measure types that came up that are in use also that I'll talk about in a moment, but those were the two most common. We also asked people how they were using accessibility. So what types of decision-making processes accessibility was used for. Corridor planning, transit planning, multimodal planning, those all came up. Prioritizing projects, equity analysis, long-range planning, and scenario analysis. Those were all areas where people were using accessibility measures to inform decision-making. We also asked people about the barriers and opportunities to using accessibility measures. One of the big barriers that came up was just staff time and technical expertise. So as I mentioned, when we looked at particularly the academic literature, but also the practical literature, we see that there are lots of different types of measures. And within any type, there are lots of different ways to formulate a measure. And I think that for some people, that can be overwhelming, especially if you're at an agency that doesn't have a lot of staff time to dedicate to calculating original performance measures. So that was definitely one of the barriers that we came across, both in terms of the people who weren't using it at all, as well as the people who wanted to use more sophisticated measures, but didn't feel that they really had the time needed to develop their own novel metrics. Some people also mentioned technical limitations, so limited data availability. Pedestrian infrastructure was a big one that came up. So we talk about that in the report, and Louis did a great job of laying out the details there. People also talked about limited ability of their models to represent, for example, pedestrian travel and the choices that people make for pedestrian travel. People also struggled sometimes conceptually with how to formulate the measures. So they weren't really sure how to design a measure to capture the specific application area that they were working in order to measure the sort of the needs that they were interested in addressing. Some people struggled to think about measures that would apply across different contexts. And then the last barrier that came up was that, you know, most agencies are using lots of different performance measures, and other measures are mandated. So it was hard to find the time and to sort of devote the same level of energy to accessibility measures because they weren't mandated. In terms of the opportunities to use accessibility, a lot of people were interested in expanding their use. Not everyone, but a lot of the people we spoke to were. So there were people who said, you know, we don't use it, but we would like to be using it. There were also people who said we use it routinely, but we'd like to use more sophisticated measures or improve the measures we're using, or use measures in new decision spaces. So, you know, we've been using it for corridor planning, but we'd like to also use it in equity analysis, things like that. Another thing that came up was that there's a potentially high payoff even for using simple approaches. So applying the concept itself can be a powerful tool in terms of shaping the conversations around how we plan infrastructure and land use. And so that was something that came up as a sort of an opportunity. So even for those who didn't have the ability to do their own customized analysis, just using accessibility as a concept could be helpful. And then for those who are using measures, I think there was some intimidation around using simple measures, but a lot of the advice we got from practitioners was just that, you know, not to worry so much about the details of the measures. I mean, obviously to try to make the measures represent what you want, but that really just bringing in a measure that represents the relationships that you're interested in is really helpful and informative, even if it's a simple measure or if it's just the concept. And then we also heard from people about some emerging application areas. A lot of people expressed interest in using accessibility measurement more in their scenario planning, and also in terms of proactive investment decisions, and also in terms of thinking about non-motorized travel. So that was the kind of the research that we did that came in and inform this guidance. I'm just going to kind of point to a few highlights from this guidance. This is basically when I have students that come into my office and ask about accessibility measurement. There's a few spots in this book that I always flip to. So I just wanted to highlight these because I think they're really useful. So what's inside? So this is the table of contents. Don't worry about the details. There's a few things I just want to point out so that you know they're there. And don't worry about the details of what I'm going to show. I just kind of want you to understand what's in the resource because I think it turned into a really helpful document, in large part because of the great panel we had, I should mention. So the NCHRP projects always have a panel of practitioners that help guide the work. We had a really excellent panel. And I think as a result, the document's actually quite useful. So we lay out different types of accessibility measures. So I mentioned earlier that there's more than just access to opportunities and proximity. Those are the first two listed here. Don't worry about the details. There are several other types of measures that include other dimensions of accessibility. So things like if you're trip chaining, you know, where can you get over the course of the day? Or if you're thinking about all the different options that you have in front of you, you can pull log sums out of a travel demand model and use that as an accessibility measure. So there's all sorts of different types of measures. We also talk in the book about conceptual and qualitative measures that we think do a better job of capturing individual experiences. So Louis was talking about this, you know, there are these and where you are and what time of day it is. And sometimes we have to kind of get outside of a traditional data collection box to think about an individual person's experiences with the system. And so some of those conceptual measures can help us do that. We lay out 6 steps, and each step has a lot of detail about how to go through it. I'm going to highlight a couple of things from a few of the steps that are in the book, a few of the tools we give. So one step that we lay out is just to screen candidate measures. So there's all these different measure types. It can be overwhelming. As a first step, what we do is we ask people to reflect on the needs for their specific application area, and then they can use a simple rubric, and we have a discussion of this rubric to narrow the field, to think about, you know, are there 1 or 2 candidate measures we want to focus on first, and then think about how we would design those 1 or 2 measures. So what this rubric does, you can see there's a column here that's about practicality, how practical is a measure. And you can look and see that the green boxes show you measures that are very practical. So they're easy to estimate, they're very clear. So proximity measures and conceptual measures, the top and the bottom light up as being very practical measures. And then you can think about other considerations, the kinds of concepts you want represented, and try to think about which measures might be a good fit. So this is just kind of a screening tool. We also break apart the different dimensions of different accessibility measures. So Louis spoke a lot about impedance. We have a whole discussion about impedance, also different types of opportunities, different travel modes. So we sort of break apart accessibility measures into their constituent parts. And then we point you to a lot of different resources. I definitely don't want you to look at the details here. Sorry about all the text. But the idea here is just that we have a lot of different tables with examples of software that can be used to estimate accessibility, lots of different leads to data sources. So if you're thinking, I'm not sure where to find information on travel time, what are my options there? You can get a whole list of options and think about what you have access to. And we did try to find a lot of options that are open source and freely available. Sometimes they're not, because that's just not what's available, but we tried to highlight those opportunities. We also point to several documents that provide more detailed guidance or other insights that can be helpful with accessibility. So for example, the SSDI guidance, I'm pleased to say, is in here, because I'd feel really bad if it wasn't and we were giving this talk. So there's a little paragraph about it, about how it's useful, and then a reference to where to find it. There are a few other really helpful guidance documents in there as well. There's the QPED, which is a way to interview people about their pedestrian experiences, which can get, similar to what Louis was talking about, at these individual level experiences with the system. So lots of great resources in terms of data, software, and also other guides, other guidance documents that can help you once you've picked the type of measure you want and you're interested in more information, or you sort of have a sense for where you are from going through these steps. We also, in step 5 of the how to measure section, we lay out step by step how to calculate each of the measures that we profile. They're very brief descriptions. They're not, a full level of detail, but they give you a sense for what you're up for. And in some cases, there's guidance that we refer to that gives you more detailed information. So for example, for the access to opportunities, the Accessibility Observatory has a great resource that we profile here for more information on those types of measures. And then we just provide a lot of different examples of how accessibility has been used by others. I think these are really useful because sometimes people kind of, they've seen one or two types really often, but they're not really sure how to make it work in their situation. I was surprised at the huge number of ways people use accessibility in different contexts. There were some really great examples here and great ideas, and I don't want to go over time by going into it. I just want to mention that we have a lot of really great illustrative examples if you're just kind of trying to brainstorm about how you might think about accessibility for different application areas. And that's most of what I have to say. There's a link here and a QR code if you're interested in checking out the report. I think that I can also drop the link into the chat unless it's already in there. And I should also acknowledge the other folks that worked on this project at UT and Kinetics, and then the really excellent panel that we had at NCHRP and the excellent staff we had there. So that's all I have.
Great, thank you very much, Dr. Rowangould. I invite both panelists to stay on camera for this next segment where we have a couple of really good questions, hopefully, that will spur some discussion, maybe on and offline here. Starting with a question about using accessibility at the agency level. For those agencies that don't currently have the capacity to fully embrace accessibility analysis, are there simple measures they could use without too much investment?
That's a great question. So one of the things that came up I think I mentioned was just that using the concept itself is really helpful. So even if there's no effort to create a measure, to just talk about the concept and to think about how it might apply. There are also a lot of off-the-shelf tools that we point people to that you can use to create measures. And then there are also relatively simple measures. So like those proximity measures are pretty easy to estimate if people have, some basic GIS capacity and some basic data. So there are lots of different options for people that are just starting to think about how to use accessibility.
Great. We talked a bit about the availability of pedestrian networks. First of all, for those interested in starting to use them, what are the quickest ways for agencies to start using pedestrian networks in their planning processes?
So, it's interesting. This is actually an emerging area. It's someone asked whether there's a lot of pedestrian networks, or there are pedestrian networks in practice. And I think Seattle has developed a sidewalk network. I've seen that one. I haven't seen many. There's a lot of new papers coming out now about trying to automate the process of developing a pedestrian network, automating it based on other GIS layers, or automating it based on aerial photos. But it's still an emerging area. I don't think there are well-established methods for building out your pedestrian network yet. I think it's kind of still an area of on the frontier of research.
Along the lines of automated methods, I'll just quickly plug a white paper that we're working on in terms of automating pedestrian networks from centerline networks, including crossings, which we piloted on a couple of projects. And so if you're interested in that, sign up for our newsletter. Do you have any thoughts about incorporating desire paths into pedestrian networks, or links along highways or other roads that don't have pedestrian facilities? Would you consider a level of traffic stress impedance for this type of analysis?
Yes, absolutely. I mean, I think I would include unofficial links, even if they're not part of the official transportation network, and then just try and characterize them accurately in terms of what is their surface? Are they wheelchair accessible? Are they uneven? Are they, and then you can use that data to characterize who it's accessible to and what the impedance imposed by that path is. Yeah. So, I just want to make a quick comment about level of stress. I think level of traffic stress is very relevant, but here in South Florida, one of the things that comes to mind for me is that the heat and direct sunlight is also, I want to expand the concept to environmental stress. It's not just traffic stress.
And I would actually expand that when we're thinking about like the intersection of a person's identity and their experience. When we think about safety and a feeling of safety from crime or safety from police, it often intersects with someone's gender or racial identity. So it can get quite complicated.
Many of these concepts are somewhat weedy. They're hard to communicate about. Perceived speeds, impedances due to LTS, level of traffic stress. These can be hard concepts to convey. You have thoughts about how to talk about these issues in a way that's helpful for folks who aren't sort of in the practice in the industry?
I mean, the term I've seen other people use is, this is the experience distance, or the experience time. There's the actual time, and then there's the experience time. And even though it may only take 12 minutes, it may feel like 20 minutes because of how uncomfortable it is. So, those are terms that I don't know, Dana, do you have, mostly I hear people say the experienced or perceived, sometimes perceived or experienced time or distance.
Yeah, those are the terms I've heard too, and not just for time or distance, but just, overall the experience of whether it feels like something they want to do or is pleasant to do. I think I'm just thinking back to some of the examples we had from some agencies. There were some good examples of people kind of profiling like day in the life, or, you know, different types of people and how their experiences would happen in a system. So I think there are some kind of neat ways to communicate in public audiences or during public engagement processes that are pretty intuitive, because, you know, people do have an understanding of experiences with transportation system from their own experiences. So it's nice that we get to, you know, ride off of that and build on that.
Great. For those agencies that are currently running their own accessibility shop, what might they be missing if they're using centerline networks at the traffic analysis zone level, let's say, that they could be learning by using pedestrian networks with higher resolution grid cells, for example, as origins and destinations?
Yeah, I mean, if you're using TAZs and you're using roadway networks, you're really not that close. You're really not that close to measuring pedestrians. I mean, it's better than, you know, you got to start somewhere, and I understand that, but it's not, you know, so much in my experience depends upon the quality of those crossings. I have a coffee shop that's within a quarter mile of me, and I've never walked there, even though I love to walk, because it's across an 8-lane road where people are driving 60 miles per hour. I've never walked there ever once. By distance, I should be walking there a couple of times a month. So, you know, it's just not, and micro scale environment, things like bridges, tunnels, crossings, off-road paths, these all matter quite a bit when people can be quite sensitive to distance when they're pedestrians. The shade, all of these things matter.
Well, there's a lot more to talk about, but I think we'll wrap it up there. Thanks to our presenters, Louis Merlin and Dana Rowangould, and to SSTI staff members Megan Link and Chris McCahill, working behind the scenes to keep this thing rolling. Keep a lookout for future SSTI webinars, and we'll see you next time.